Hello everyone, and welcome today to today's webinar on Geotab's Big Data Resources. I'm Aaron Jarvis and I'll be your facilitator today. I'm going to quickly run through an agenda for you and then hand you over to Paul Staub, who is our resident data expert. So today I'll be covering a quick company overview for you. We'll then move on to Paul, who's going to tell you what big data is, how we use it within Geotab, and what we're doing in big data and machine learning. So I will quickly move through a company overview so you can get into the good stuff with Paul. Geotab truly is the best telematics company in the world. I can say that because I believe it, and that's why I work here. We have a huge ecosystem of over 400 partners, over 1,400 employees and offices all over the world. And while we like to stress that we have the largest penetration in Fortune 500 companies, we're also the telematics company that best serves small and medium fleets. In the UK, I think it's important for you guys to know that we have a local solution engineering team. We have a wealth of industry knowledge and experience in the UK market specifically, and also a great team across Europe of over 70 people. I'm going to hand over now to Paul, who's going to talk to you about how many connections we have generally, and then move into big data. So, Paul, over to you.
Perfect. Thanks, Aaron. All right. Also, welcome from my side. Welcome to this second series of webinars. So, starting with the big data resources. Shortly to my background, I'm since 4 years in the space of data science, and I entered it with my master's degree, so I'm very fascinated about it. I have a lot of passion and motivation around it. I'm trying to transfer this today to you to see the same effect. Okay, so on this slide, what you see right now, you see that we have currently 2 million connected vehicles globally. If you take all the GPS data which we collect on a daily basis and just put them on one global map, you would see the following, what you see here. So all the lighter blue spots are actual GPS points. So you see that from the North American side, we have a very high dense area. And then we are also located in Southern America, in Africa, and as well as in Europe. Altogether, from the raw data side, we collect over 4 billion data points daily. And then when we take the data, we transform it to make it more useful, to structure it, we actually generate 40 billion data points per day. So this overall creates like one of the richest telematics data sets in the world, including data like GPS, traffic data, accelerometer data, engine data, weather, driver behavior, and much more. So let's get into the details here and let's get going. Firstly, what I want to cover is what exactly is big data. Big data, many companies talk about big data, but it's really not the same everywhere. So there's some ways how you can measure big data and how you can think of it and compare it. So one way of thinking of it is to use the 4 V's. The 4 V's consist of volume, variety, velocity, and veracity. Volume must be the easiest. It's the amount of data you have. So for example, since Geotab started in 2000, we have collected tons of data. So every day we are adding now 4 billion data points and taking this from the past on, and we have a very huge amount of volume of data. Variety is the other one. Variety is the different forms of data which we have. So if you only have one type of data, which could be GPS, for example, it's not as rich as if you have different types of data. We have 4 different raw data types with different subcategories I can explain in a few. So therefore, it has a high variety. Thirdly, velocity. So velocity talks about how fast data comes into our system. So in which frequency, and that's what I already said, it's 4 billion per day. And then the last one, veracity. Veracity, the uncertainty of data, maybe the less so tangible, self-explanatory term, which is actually giving you the value of data. So is the data which is incoming already valuable? Is it structured? Does it have meaning? So if you only receive data which you cannot use, it's not really useful, right? So all the data which we receive, they are coming certain on a certain basis, and we know what they mean, and we know how to work with them. This slide gives you a brief introduction of the different data types we work in. So as I said, we are not only collecting GPS information, but much more. So one way to see it, if you look at the left side first, we separate the data types into 4 different ones. It's GPS, faults, status, and accelerometer. So GPS data would be, as you would imagine, longitude, latitude, the location data, also the device information, so which device sends us this data, the driver information, which is linked, the GPS speed. So also from the next GPS point, we would gather the speed and then the date and time. From the faults, for the fault side, we're receiving 2 things. So one fault type we're receiving actually from the device itself. So whenever there's an issue with our device, or we collect like a fault voltage, we can collect this information, as well as from the OBD itself. So if the device is connected to the OBD, we are also getting the OBD faults, which we then translate and put into the Geotab platform. Those are separated after the diagnostic code, and they have a data field often included, which gives some other information. Then we have also status information. Status information is also coming from the OBD, which entails, for example, the RPM information, seatbelt usage, and so on. And lastly, we have accelerometer data. So we have one acceleration sensor on our device installed, and that one is sending us the acceleration values for the 3 directions we collect. So forward, backward, which is the X direction, sidewise acceleration, which is Y, and up and down, which is Z. And from this whole amount of raw data, we're actually calculating values, which you see on the right, and the yellow ones, which are exceptions and trips. And then we also gather other information into our systems, which is geospatial data and demographic data. Now going to the fleet industry trends. So that's maybe the easiest way how you would think how you could interact today with our big data source. So in each Geotab instance, you will find under Dashboard and Analytics the section Fleet Industry Trends, and I will just briefly walk you through some examples here. So here right now you see that I'm logged in a database. It's an example database G560 with the trends section. And if I scroll a little bit down here, you see, so for example, the age of fleet vehicles is an average 2019. The average age of fleet vehicles is 4.4 years old. What you could use instantly here is this section, for example, the Geotab Vehicle Data Access tool. So what we basically do is, so we look for all vehicles which we have, we determine from the VIN, the model and the make, and then we check what data do we get from the vehicle. So let's say I want to give a customer I want to sell a device, or I want to use the device myself, and I have a Audi A5. So if I type in A5 here, I would get the A5, and I would know in which section the vehicle I chose is. So here you see, for example, that the full support is 91. You have fuel support 100%, ODO 93%, VIN 100%, seatbelt 98. Why do you have those weird numbers here, 93 and 98? It's because from all vehicles which we have, 93 of them are sending us odometer and 7% not. And having here a higher number determines that it's more likely that you will also have odometer information if you put the device into a Audi A5. Why it could not work is, for example, that some vehicles might have an older firmware version on, or some other issues on the installation. So that's why sometimes those percentages do not go until 100. Good. So that's one thing how you could use the big data which we collect daily. So you can compare yourself, and if you go on further, you can compare your idling time by vehicle usage. So you can group your vehicle into a vehicle usage type, And based on that type, you can check what's the average idling time we get over all vehicles which we have worldwide. As well, you can check here at the end, what's the number of incidents in average per 100 kilometers, and also which type of incident, harsh braking, hard acceleration, or harsh cornering is the most likely one. Next one I want to show you is the commercial mobility recovery dashboard, since the actual situation shows us that activity among all fleets went strictly down. So we brought something out, which is the commercial mobility recovery dashboard, to show the public, or to make it available for everyone to see what's the status per country, how companies are recovering, and especially also which industries are recovering faster. This is what we are doing by measuring the activity of the vehicle. So we have an average of trips normal companies do on a typical day, and this we can compare to the data we collect nowadays. So if we move to the commercial mobility recovery dashboard, which I have here in the second tab, you will find it under Geotab.com, commercial mobility recovery dashboard. And if you scroll down here, you will see, after a little bit of loading, that here, for example, you see an average of Europe. So for Europe, we have currently reached 89.25% to the normal activity compared to pre-COVID levels. For North America, we have 94.67%. And here underneath, you just see that this percentage increased quite fast. In America last week, so 5.5%, it was up. In Europe, 3.5%. And then later on here, you see actually you can just type one country. So I'm currently sitting in Germany, but let's look at United Kingdom, since that's most of the region most of you are from right now. So you see, for example, that the average activity was 100% up to the March 17, and then somewhere around March 17, restrictions came in, and the activity of all fleets together went dropped like to 50%. And then we see like some dips here. Those are actually public holidays. So on public holidays, we had very less data, and then you see already the increased activity again. So currently we are around 72%. So you're doing good. You're doing better and better every week. Comparing it to another country which did a very fast increase, actually, just to give you a picture right now, is France. France crazily went down to even less percent. So they had very tight restrictions, and then they loosened those restrictions for those businesses quite fast again. So the fleets their activity went up faster again. That's all to that data. You can just check it out by yourself. You have also some industry activity data. Also, you can sort here by countries. So we have 3 industries you can check out as well: business services, construction, and freight transportation. Coming to the next section, which is leveraging big data with Geotab. So more in depth now. So here I want to first give you the brief overview of the big data continuum. So how does the data get to the way how we can use it? So first, on the left side, what you see is the data collection. So as I told you, we are collecting 4 billion data points a day, raw data points. Those we are transferring securely to a centralized data lake, where we have the data anonymized, secured, stored. And from that centralization, we are doing the enrichment. The enrichment contains running different pre-processing steps, pipelines, which run like on a daily basis, or even maybe every hour, as well as doing different machine learning steps on it. So from that 4 billion points, we're generating 40 billion points. And now we have, from the data, we have created valuable data, which we can instantly use. So as soon as it's enriched, we can use it. We can feed it into different locations. So one is feed it into add-ins, to feed it into, like you saw right now, into the fleet industry reports and so on. So that's what I will go into depth now. To give you an example first, how do we gather insights from the environment? For example, here you see one vehicle, and each vehicle is for us like a sensor. So what you can see here first is you can gather the information of the traffic left and right. So is the car moving? Is the car moving fast as normal on the road speed? Is it accelerating? Is it braking a lot? And then you can see on the street as well there are some potholes. So how about that acceleration of the potholes? Are they getting measured? Those we're sending them in as well. And then we're also measuring, for example, the wipers and the temperature of the vehicle itself. So those are also inputs we gather. All those inputs we are collecting, anonymizing, and then putting also online on a platform called data.geotab.com. So this is a platform, if you haven't heard of it, that contains data sets which we aggregated from all the fleets, for sure anonymized, and which you can use and leverage already today. And this platform entails also different tools, which I will be using in a few minutes. But to give you an overview, so what you can find there, what big data you could use there already, are like here right now, 3 different types. We describe here as urban infrastructure. So we have data sets around hazardous driving areas. So where are risky areas and where do we collect a lot of braking events? So let's say 3 cars are sending us braking events. So we can mark those ones as risky areas. Then another one would be searching for parking. So where are vehicles circling in an area and therefore searching for parking? Cell coverage, dark spots. So what's about the connection of the cellular network? Areas of idling. So where do cars normally send us a lot of idling events? And then we have road impediments. So where do we see some road impediments in the streets, intersection and sites? Lastly, we have 2 other sections, which is weather. For the weather, we have temperature information, barometric pressure, and precipitation. So when are we using actually the wipers? And then location analytics, we have fuel station metrics. Where are vehicles filling up their gas? Service center metrics and truck parking locations. Good. And one more I will show you in a few is the COVID data set, which we added as well. Good. Here you have a demo around the tool Geotab Ignition, which is inside the platform. Let me walk you to the demo. I will stop this video right now because I want to show you the tool in live. So if I switch back to my other tabs, and I just type in Geotab data.geotab.com, I come to this platform here, and basically here I can learn around the different ecosystem, our data which we're gathering, benchmarking, fun facts, and vehicle locations. Different data sets I just listed are here. So you can find here the intelligence data, the weather, urban infrastructure, location analytics I just showed you, or I just explained. One more which came in here is the COVID-19 mobility impact. So all the information which we put on dashboards around the activity is also available to get extracted. And you can always view the data sets just by clicking in here, and you see an explanation per each data set. Okay, next what I want to show you is a way how you can already, as a MyGeotab customer and also public person, you can leverage the tool called Ignition. So here on the top right, you see the Get Started button. As soon as you click here, you see that you can click here on Access Geotab Ignition. So that's the tool you can use to go through the public data sets. As soon as you click on it, you will enter the Geotab Ignition platform in a separate tab. We have enhanced this tool actually a few days ago, so you can now actually save queries and title them exactly. Here on the left side, you see the data sets. So that's how a our data scientists would daily work. So on the left side, you have all the data set marked. Here, for example, in the public intelligence data set, you have again the COVID mobility impact data sets with different metrics. You have location analytics, you have urban infrastructure and weather. If I want to look, for example, at the temperature of a location in Spain, for example, just 1 hour ago, I could go here into the temperature, and then I have like a preview of the table. And now I can start coding and start looking into different information and filter those. So for example, if I want to look for Spain, I would look, for example, I would draft a query where I would check that the column country equals Spain. And then I could extract all columns which are named Spain and then do further analysis on those locations and metrics of the values. You don't need to do this by yourself. We have here some examples for you included. So as soon as you click on library, you will be presented some examples. Some of those are, for example, likely speed bumps in Netherlands. We could have a look right now, or some hyperlocal temperature in Toronto. Let's check out the speed bumps in Netherlands. So as soon as we click on it, we will have an automated query already inserted here. And all what we have to do, we don't have to think about this logic. We have to click visualize, and then it opens a separate window, a new window, and you then see a map, and you see those values get calculated quite fast. So what we did here in the query, just to give you some explanation, we looked at all acceleration values which we received like in the Z direction, which were higher than usual and for a certain location. So this is for the Netherlands. That's why we have like here, we have filtered for NL. And we can now, for example, zoom in and look at the different meanings. So we want all average accelerations above 1 in Z. So those are here marked from a lighter color to purple. And if we, for example, go a little bit more in depth here to this location, we could actually check out why do we have those values collected there, by just decreasing a little bit the scale of those points. So now we can zoom in quite better. So we have here a street called, I cannot even pronounce this, but let's look at this street example here. We can change the satellite. From there, we can still not like see maybe what's the reason for this, but we could move also via the street view person here onto the streets. And then when we look at the street, what we see actually is we have here some bumps in the streets. So those we collected from quite some vehicles before, those acceleration values, and they match up quite well with this one here. Good. Giving you a fast other example, if you click back to library and then you click on hyperlocal temperatures in Toronto, for example, we would now discard the changes and continue. You can also change that other one from before. So if we go back to console, we have those two windows: console giving you the code and the tables, and then the map, the type, how we show the data. So if we now moved back to the console and looking at the hyperlocal temperature in Toronto, we can change this information to, for example, say we want data of the country instead of Toronto, let's say Spain. And now we could query all the data, all the last data. What we did here is we only look at the last 3 hours data. So let's check the weather. I have pretty bad weather currently in Munich, but let's check if the weather is better in Spain for the last 3 hours. So you see here that we only filtered for the last 3 hours. And when we again visualize, if we click visualize, we see here that the query is calculating. On the left side, you can change other things as well. You can change the coloring of the different information you're collecting, and you can here, for example, also on the right top side, you can increase the window size. If you just want to demo the map, for example. Yeah, so now it's finally done. What it did is it got 36,000 values back, which were all tagged with Spain for the last 3 hours. So we see here for the nice island some values. We can zoom into Madrid, and when we zoom into Madrid, we see average values. Let's change this coloring a little bit to represent hyperlocal temperature. So we start with 8 degrees and going to 25.7. I would have imagined we would have higher temperatures, but Madrid looks also not too warm right now, so it's like 15 degrees roughly. And if we zoom out, we could check into Barcelona. So in Barcelona right now we have higher temperatures, so you see that more red marks, which is around 20 degrees. And let's go to one of those beautiful islands in the south. We would see a temperature, even warmer. So what a surprise, 22.9. So that around that. Yeah, so you can try the tool out yourself. You just need to log in with your MyGeotab account, or you can create a public account if you don't have a MyGeotab database. Yeah, there are other libraries you can leverage, but that's all I would show you for now with this tool. Good. Moving back to the presentation. So next one is I want to introduce you to our MVP team. So we have minimal viable product team working on data innovation services for our partners and customers. So currently already today, our data analytics team is not only researching inside themselves, but we like to mingle and partner up with our partners and customers on different ideas and different solutions. So here are some listed, which include smart city, fleet, site locations, environmental sensing, EVs. So one example is we did a lot of work on the EV side. So since this is a new area, for example, the range prediction is a big topic. We can help here to give the customers a solution that predicts for them what the typical EV range, for example, would be. So there are different kind of solutions we are working on already with customers, partners, and we're happy to come together with you to work on even other and new ones. Next, yeah, just giving you a few more graphics around the data, which I showed you in the Ignition platform. For the hyperlocal weather conditions, you can, for example, if you're a city or if you're a fleet, you can take this data and just aggregate it by hour and then see the different changes by hour. So for cities, for example, you can see, for example, different bridges having maybe very low temperatures at night, which you should not pass as a fleet owner, having like trucks in their fleet. Or you can see as a city, you can see areas where you have very high temperatures, like local high temperatures. And the same with the weather conditions. Here on the left down, you can see the precipitation. So where is it raining right now? So as always, it's raining around New York. And then in Miami, you see that it's all green and there's no rain. Here you see the hyperlocal temperature gathered over one day, one time. So what we did here is we compared our Geotab data aggregated with an official source which is NOAA. And here what we found out is that the patterns match quite good. So here on the left top picture, you see, for example, that you have some light yellow spots, and the same yellow spots you see almost at the same locations on the right side as well. So basically, we have here a monitoring system already for like very dense located countries with Geotab vehicles. So you can build from it. The same how planes are helping us with the weather prediction, and we could help weather predictions to be even better with the Geotab data, which you could source right now already from the Geotab Ignition Geotab Datacom platform. Just another example here, the polar vortex below, which showed, like, I think that was somewhere sometime in February, like very low temperatures surrounding Toronto, and you very nicely see the circle of the vortex with the different temperature readings going up when you go to the south. One thing here I want to outline is that we can now not only insert one data type, but we can take different data types together. So for example, we want to predict dangerous driving locations due to weather. And we can do this by taking information from weather, what precipitation we have, what traffic volume, and then matching this with different movements data, what we gather from the various types of vehicle fleets. And since we have like a hyperlocal weather aggregation of 150 meters, this quite adds pretty well. So we can really define area spots, which you see here on the left in the heat map, which are dangerous locations, where we see much more braking events than in the other rest of the locations due to the weather. Good. Another way how you could leverage as a customer or partner the big data which we put public is using it by an add-in. So if you develop an add-in for the Drive app or for the MyGeotab solution platform, you can communicate with the big data resource and then just extract the information and then put it on the maps, for example. And we have one example add-in here, which is the add-in Drive Tracker, which just shows you the logic how this is being accomplished. You could do it by yourself and by extracting, for example, the open temperature readings and then giving some insights here it's inside the add-in. And then one more product feature which we launched, I think last year, which is the data science package. And the data science package is basically a tool, like the big data tool, which we provide to you as an option if you want to commit to something like this, where you want to study more the big data of your fleet. It's available in the marketplace, so you just have to go to the marketplace and you see all information there. But basically, it's giving you in 24 hours after you sign in all the data which you collected last year until now, and then adding every data point each day. And what's special around it, it's not like you extracting the raw data yourself via the API in the MyGeotab platform, but here we are already pre-processing the data. So here you see on the right side, for example, Geotab data. So you will have data sets which are structured and already put together for you to use. So it's accelerometer, fault code lookup, GPS status code lookup, trips, and VIN of information, which already has been interpolated and worked on. And as well in this package, we provide you with some example queries and Python notebooks. So data scientists normally work with Python notebooks, and those code examples, code snippets are available on GitHub for you to just get started as soon as you want. And we recommend this tool for customers which have fleets above 500 vehicles. And we recommend to use it only when you have already 1 year of data collected, since really the volume part of big data quite makes sense here, because you might want to compare, for example, the data of today to the data of last year with this tool, and that's only possible after 1 year. Good, almost going to the end, which is big data plus machine learning. So we have also a team of researchers in our data analytics team. So we're not only aggregating, analyzing, but we're also predicting and doing various of algorithms around the data. So in this section, I just want to briefly introduce you to some of those topics, which is the battery degradation, for example. And here we're taking the cranking event. So every time you start the motor, you will have a cranking event, where the voltage normally drops from a like around 12 volt level down because it's extracting the energy and then turning on the alternator, so putting it to a higher level. So we can analyze and we can see patterns and we can determine invalid cranking events. So invalid cranking events happen more and more often to the end of the life of batteries, and having those events detected, we can gather information of the health of the battery. Another project or what we just published is actually the impact of temperature on EV range. So here as well, we did some data analysis, some feature selection, some gatherings from like all the vehicles, electric vehicles we have currently in our system, and then we looked how the battery actually was affecting the range of the car. And here is one example, which is the BMW i3 2016 with 18.8 kilowatt hours. And what we saw, you can here now move around the temperature, and at 5 degrees Celsius, for example, and the average vehicle range was 117 kilometers. Some of the vehicles showed only 73, others showed 155, 152. So yeah, just click on the link. If you're interested, you can check out this tool, which has been just published, I think last week or a few weeks ago, and there you can choose different electric vehicle types to do this analysis. And then lastly, one cool tool which we are working on is the determine vehicle similarity. So what we did here is called clustering. So we took the data from all different vehicle types which we have in our system, and we gathered them. We did some benchmarking, and we could extract actually informations around which vehicles are typically the same. So here, for example, if you click on one bubble, it will give you those surrounding other vehicle types. So for example, you see that next to like one type of vehicle, Silverado, you might see as the next one the F-150, another pickup vehicle. So those type of vehicles are based on their driver behavior, and other metrics of the vehicle are clustered together. Okay, that's all from presentation Big Data Resource. I hope you enjoyed the presentation, and I'm open now for Q&A, and hope this made you also passionate and motivated around the big data space which we're entering.
Thanks, Paul. Really great presentation. So we'll open up quickly now for any questions that you might have. And Paul, I will open up with a couple that we've already got. So maybe a challenging one. What do you think the next big thing will be in big data related to the vehicle? You know, what's the next thing that Geotab are working on?
So the next big thing is really what I showed you just in the previous slide, which is the using unsupervised machine learning, which is the way that you don't know what exactly you want to predict, but it's the way where you cluster different same vehicle types together and then derive more informations of clusters of vehicles. That's quite exciting.
Great, thank you. And then the next question is quite a practical one. If a customer has an idea for an MVP, how do they present it to us at Geotab? What's their route in?
Good question. First, get in contact with your account manager or the person you know in Geotab, and then he would connect with the MVP team. Probably someone from us from the big data side, Jorge, Gonzalez, or I would connect as well, and then we would see the next steps, what is possible.
Great. And then, conscious that we've actually hit the end point here, my final question is, based on the data that you've got, how do you think the weather's going to be this summer in the UK?
Yeah, looking into the future, so you always find out like if the weather is bad at this time, it must be good in the summer. So I assume, and I hope it will be the best.
Yeah, maybe based on that, we should go to Madrid. It seems colder there than in the UK today.
True, good one.
Great. Well, thank you very much, everyone. That's the end of the session today. Thanks for joining, and we look forward to finding you on the following webinars in this season. Thanks a lot, Paul, and speak to you all soon.